Good morning, students. Today we are going to discuss about grammar's rule. Today we are going to discuss about what? Grammar's rule. This rule can be applied only when the coefficient matrix is a square matrix and non-singular. This rule can be applied only when the coefficient matrix is a square matrix and non-singular. If the coefficient matrix, the determinant value of coefficient matrix is a square matrix and non-singular. Okay, now consider the system of equations. Consider the system of equations. Let a11x1 plus a12x2 plus a13x3 is equal to b1. Second equation a21x1 plus a22x2 plus a23x3 is equal to b2. Third one a31x1 plus a32x2 plus a33x3 is equal to b3. Where delta is equal to the coefficients of, we are going to write the coefficients of x1, x2, x3 in the three equations. So, delta is equal to a11, a12, a13, a21, a22, a23, a31, a32, a33. This is not equal to 0 because here coefficient matrix, the coefficient matrix, determinant value of coefficient matrix is non-singular. So, delta is not equal to 0. Now, delta 1, we are going to take delta 1. How do you write delta 1? Here, first row will be replaced by, first column will be replaced by B1, B2, B3. Here, first column A11, A21, A31. The three elements are replaced by the three elements B1, B2, B3. Okay. B1, B2, B3. This is called as delta 1. First, we replaced first column by B1, B2, B3. So, on the second column, third column, there is no change. Second, third, there is no change. This is called as delta 1. Similarly, delta 2. How do you write delta 2? Yes, very good. You think? Yes, it is correct. We are going to write B1, B2, B3. Replace the second column. Second column here A12, A22, A32. We replaced by second column, that is A12, A22, A32 by B1, B2, B3 here. B1, B2, B3 and first column, third column there is no change. This is called as delta 2. Now delta 3. How do you write delta 3? You think? Yes, it is correct. That is third column A13, A23, A33 replaced by the same three elements. We write third column as B1, B2, B3. First column, second column, there is no change. It is called as delta 3. Okay, first we write delta and delta 1, delta 2, delta 3. The four values we find out. Okay, now Grammar's rule. Applying Grammar's rule, x1 is equal to delta 1 by delta. x2 is equal to delta 2 by delta. x3 is equal to delta 3 by delta. Okay, this is the Grammar's rule. So listen, I already told the square matrix, coefficient matrix is a square matrix and non-singular. Why the coefficient matrix is non-singular? You think? Listen, here delta x1 is equal to delta 1 by delta. x2 is equal to delta 2 by delta. x3 is equal to delta 3 by delta. x1, x2, x3, all the denominators are here delta. If delta is equal to, suppose delta is equal to 0, what happened? Delta 1 by 0, delta 2 by 0, delta 3 by 0 not defined. So, this reason we take square matrix is non-singular, that is not equal to 0. If delta is equal to 0, then the Grammar's rule cannot be applied. Are you understand? If delta is equal to 0, then the Grammar's rule cannot be applied. Okay, using the Grammar's rule, we are going to solve example 1.25. Solve by Grammar's rule the system of equations x1 minus x2 is equal to 3. 2x1 plus 3x2 plus 4x3 is equal to 17. This is second equation. Third one, x2 plus 2x3 equal to 7. This is third equation. But you listen the three equations, some variables are missing in the first equation and third equation. Second equation, x1, x2, x3, three variables appear in second equation. But first and third, so variables missing. So we write the three variables. How do you write? The solution starts x1 minus x2 plus 0x3 is equal to 3. Second equation, there is no change. 2x1 plus 3x2 plus 4x3 is equal to 17. Third equation, which is missed? Yes, x1. So 0x1 plus x2 plus 2x3 is equal to 7. Let me write equation number 1, 2, 3. Now the coefficient matrix. How do you write a coefficient matrix? Yes, the coefficient of x1, x2, x3. The first row listen 1, minus 1, 0. Second row the coefficient of x1, x2, x3. That is 2, 3, 4. And third row listen the third equation 0, 1, 2. Now we are going to find the value of delta by R1. Yes, we take 1 into cross multiplying 3, 2. 3 2s are 6 minus 1 into 4. 6 minus 1 into 4. So 6 minus 4. And second symbol is minus 1 minus, and here the value is minus 1. So we remove the second column. First row cross multiplying 2 2s are 4 minus 0. And third element is 0. So 6 minus 4, 2, minus into minus plus, 4 minus 0, 4. So here 4, 2 plus 4 is equal to 6. This is not equal to 0. So delta is not equal to 0. And we are going to find delta 1. Delta 1, how do you find the delta 1 value? We replacing the first column. First column element. What is the first column element? 1, 2, 0 by 3, 17, 7. So we write the first column 3, 17, 7. Second column minus 1, 3, 1. There is no change. And the third column 0, 4, 2. Here also there is no change. This is called as delta 1. Now we are going to find delta 1 value by expanding first row. 3 into, we cross multiplying 3 into 2. 3 2s are 6 minus 4. Next minus 1 into, we cancel the second column, first row. Second column, first row, second column, the cross multiplying 17 into 2, 34. 4 into 7, 28. And third element is 0. Okay, 6 minus 4, 2, 3 2s are 6. And minus into minus plus, 34 minus 28, 6. 6 plus 6 equal to 12. So delta 1 answer is 12. Here we found the value delta is equal to 6 and delta 1 is equal to 12. Next we are going to find delta 2 value. Yes, very good. Delta 2 value, how do you find delta 2 value? Here first column there is no change. First column there is no change. Second column there is no change. We replacing third column there is no change. Second column we replacing the second column by 3, 17, 7. Now we are going to find the delta 2 value by expanding first row. By expanding first row, 1 into 17 into 2, 34 minus 28. Minus 3 into 2 2s are 4 minus 0. third answer 0. So 34 minus 28, that is 6, minus 3 into 4 minus 12. So the answer is minus 6. Now we are going to find delta 3. We are replacing the third column only by 317 7. First column, second column, there is no change. Now we are going to find the delta 3 value by R1. Here 1 into cross multiplying 3 sevens are 21 minus 17. Minus of minus 1. Here minus 1 into we cross multiplying 2 into 7, that is 14. 0 into 17, that is 0. And the third element plus 2 into we cross multiplying 2 1 is 2 minus 0. So the answer is here 4 and minus into minus plus 14. 3 2s are 6. We are adding these three numbers, we get the answer 24. So here now we find the value delta, delta 1, delta 2 and delta 3. Now we are going to applying Grammar's rule. Grammar's rule what the Grammar's rule formula? X1 is equal to delta 1 by delta. Here delta 1 value is 12, delta value 6. After simplifying we get the answer x1 equal to 2. Now x2 is equal to what is the formula? Yes, delta 2 by delta. Here delta 2 answer is minus 6 and the delta is 6. After simplifying we get the answer x2 is equal to minus 1. And x3 is equal to formula delta 3 by delta. Delta 3 is equal to 24. Delta answer is 6. After simplifying we get x3 is equal to 4. Now the solution set is. Solution is very solution. x1 is equal to 2. x2 is equal to minus 1. x3 is equal to 4. Are you understand this sum? Okay. Thank you.